So first we'll begin with Hypatia of Alexandria, and this was around 350 AD, 400 AD, so around that time. And she was the first known female mathematician to be recorded in history. And her topics of study and contribution were conic sections, which led to the introduction of parabola, hyperbola, and ellipse, as all of us have studied in our basic mathematical classes. And she was the daughter of Dion of Alexandria, who was a professor a mathematics professor at a university in Greece. And she helped write many commentaries on great works such as Euclid's Elements and Ptolemy's Almagest. She was known for studying philosophy and astronomy as well as mathematics and combining all of those fields together. And again, she is best known for her work in conic sections, which divided cones into different parts of using flat geometric planes. And she introduced, again, the basic concept of parabola, hyperbola, and ellipse. But this was a time where women in mathematics, they were not very accepted. So the Bishop of Alexandria spread many rumors about her, and a mob ended up killing her and stabbing her to death, which is very unfortunate. But that just showed that during that time they were not very accepted. But she still had a legacy, and many women followed in her footsteps throughout the years. They just had to do so quietly.
So next is, sorry if I mispronounced this, but Wang Xinhai. Her father was a doctor who taught her a lot about medicine, geography, and mathematics. And her grandfather is actually a former governor and taught her about astronomy as well. She didn't have access to a lab with equipment, so she made her own demonstrations to show eclipses with a mirror and a lamp. She rewrote many scientific texts with an aim to simplify complicated material to make these work more accessible to everyone. And she was actually born during a time when Chinese customs prevented education. So she was very fortunate to have been born into this family of scholars. And one of her statements, one of her most well-known statements is that there were times that I had to put down the pen and sigh, but I loved the subject and I didn't give up. And that led her to rewrite these works to be more accessible. And some of these are like the must of calculation or the simple calculation principle. And she did die very young at the age of 29, but she is one of the most prominent women who has a crater named after her on Venus.
So next we have Sophie Germain, and there's a theorem named Sophie Germain theorem, and this is the first general result towards the proof of the Fermat's last theorem. And the Fermat's last theorem states that there's no three positive integers that satisfy x to the n plus y to the n equals c to the n for n greater than 2. And her theorem focused on the case of all integers n that do not divide x, y, or z. And she proved this for all prime exponents less than 100. And she was also the first woman to win a prize from the French Academy of Sciences. But before she could get to that stage, we'll start with her childhood and her early ages. So she was in a family which did not approve of her and her liking in mathematics. So she obviously couldn't work on math during the daytime, so she would work during the night. However, then when her parents found out, they turned off all the heat and light, so she couldn't work then either. But she, because of her passion for mathematics, she continued to pursue that, and even in the night, she would write with frozen ink and continue her passion for mathematics. Also, she submitted many papers and mathematical analysis, but however, it was not under her name. She had to use another male's name to be actually accepted. So she had to go through many struggles, but she contributed a lot to our mathematics that we know today.
Okay, so next we have the daughter of the poet Lord Byron, Ada Lovelace, and her mother kept her away from poetry by raising her on math and science. As most of you have probably taken classes and learned about Bernoulli equations and stuff like that, one of her biggest contributions was the Bernoulli number algorithm. And she also converted various types of data into numerical data through codes used for engines. She also collaborated with Charles Babbage on his analytical engine, and this was like our first idea of a computer. And then again, she wrote the first computer program for it to compute the Bernoulli numbers. And then today we celebrate her achievements with a computer language named after her. And we also had Ada Lovelace Day, which falls in October.
Next, we have Sofia Kovalevskaya, and her topics of study were for analysis and differential equations, and also mechanics. So she was born to a family with a high status and a wealthy family, so she did have access to private tutors, and she was allowed to study mathematics, but the rest of society was not as accepting. So she did attend university, but she had to audit it, so she couldn't be like a formal student because since she was a woman. But however, because of her passion for mathematics and that she was really good at it, so they finally gave her a full status as a student eventually. And then after that, she also got her PhD in mathematics. And even after getting her PhD, she could not find a job. But finally, she was offered a position as a lecturer at the University of Stockholm. And this was only a temporary position at first, but because of all of her contributions, it turned into tenured professorship. And she only worked there for 5 years, but she was appointed in those 5 years, she was appointed as the editor of a mathematics journal. She published a paper on the refraction of light in crystals and was appointed the chair of the mathematics department. And that made her the first woman to hold a chair position at a European university. She also won a French Academy of Sciences contest and a prize from the Swedish Academy.
Okay, next we have Winifred Edgerton Merrill. She was the first American woman to obtain a PhD in mathematics from Columbia University, and she completed it in 2 years. And she had her PhD thesis was in 2 areas: mathematical astronomy and pure mathematics. She also computed the orbit of the 1883 Pons-Brooks comet, and this was only the second time that a comet had been observed. And she helped found Barnard College, which was New York's first secular institution to award a liberal arts degree to women. And then while she was on the founding committee for this, she was forced to resign from the all-male group because their meetings were downtown and her husband thought it was inappropriate. And then she also taught mathematics at several different institutions throughout her life and founded the Oaksmere School for Girls, advocating for education in women her entire life. And that was a college prep school that operated for over 20 years.
So next we have Emmy Noether, and her significant contributions were to algebraic geometry and the invariant theory. And she came up with the Noether's theorem, which is wherever there's symmetry in nature, there's a corresponding conservation of energy, momentum, and electric charge. And she, at first, like her father was also a professor in mathematics, so she came from a mathematical background. But again, it was not traditional for women to go to universities. But finally, at the age of 18, she was allowed to attend. But again, with Emmy Noether as well, she had to audit classes and was not a full-time student. But after that, she received her PhD in invariant theory and algebraic geometry. And then she used that to her theory and invariant, her expertise in invariant theory became very useful, and she assisted with Einstein's general relativity theory. And then also the Noether's theorem and mathematical proof, and she came up with that, and that was the relationship between time and energy, and that became one of the most significant mathematical theorems and contributions to the modern physics, to the development of modern physics. And also she made significant contributions to abstract algebra, which unified the principles of topology, geometry, logic, and algebra together.
Okay, next is Euphemia Haynes. She was the first African-American woman to earn a PhD in mathematics. But going back a little bit, she was named valedictorian of her high school, and after that, she attended minor normal school and she graduated with distinction. In Massachusetts at Smith College, she majored in mathematics, and then she began her career as a teacher in the DC public school system. She married her high school sweetheart who had an electrical engineering degree, and they both went on to attend the University of Chicago. And there she established and chaired the mathematics department. She was a lifelong Catholic and dedicated herself to the community, and she was an advocate for equal education as well. And while she was in the DC teaching in the DC school system, they operated a track system that placed primarily African-American and poor students in vocational programs based on their performance in early grades with no opportunities to switch the tracks. So she actually denounced the segregation system, and it was abolished in 1967. And she also championed collective bargaining rights for public school teachers.
So next we have Mary Golda Ross, and her topics and study of contribution was the pioneering Native American rocket scientist. So she was one of the first ones. And she grew up in Oklahoma. She was a Native American from the Cherokee tribe. And she was drawn to mathematics at an early age. And now we can see, like, as time progressing and society progressing, her parents were actually open to her having a proper education in mathematics. They actually felt that it was necessary, whether you were male or female, to have a proper education. So at the age of 16, she attended Northeastern University, and only at the age of 20, she already got her degree in mathematics. After that, she taught math and science to many rural children in Oklahoma. This was around for about 10 years. She did that, and then she decided that she wanted to see more of the world. And she finally got hired as a statistical clerk for the Bureau of Indian Affairs in DC. While she was there, she obtained her master's degree, and this was around the time like 1938, 1940. After that, because of her impressive credentials, she kept on getting lots of job offers actually, and she finally got a position at Lockheed Aircraft Corporation. And she helped develop many fighter planes, and her topic of study started focusing more on like aeronautical and aeronautical sciences basically. And after that, she was at Lockheed. She was one of the only female engineer and only Native American in their top secret Lockheed Missiles and Space Company. So basically at this time, now we were shifting more into the space race, and lots of we started focusing more on space basically. And her research again shifted more toward hydrodynamics, and she started working on the Agena rocket, which actually spurred the United States into the space race after the successful launch. So after doing all this, and then after retiring, she wanted to advocate more for women and Native Americans in these fields of mathematics and engineering, and she expanded several educational opportunities.
Okay, so next is one of my favorites, Katherine Johnson. She actually showed signs of her mathematical talent at a very young age. She was so academically advanced that she was ready for high school by the age of 10. And she attended West Virginia State College by the age of 15. One of her professors there encouraged her to be a mathematician. So she graduated at the age of 18 with 2 bachelor's degrees, one in mathematics and one in French. And she began teaching, but was offered a spot at West Virginia University after the state's decision to integrate graduate schools. So she left the graduate school early. She would eventually leave the graduate school early to start a family. While there, she learned about the NACA hiring mathematicians because with other women in the pool. However, her extensive knowledge of analytical geometry led her to an assignment on an all-male flight research team. There were still many taboos for women at NASA. Johnson and other African-American women did research separated from their white counterparts, and no women were allowed to put their name on a research report until one of her coworkers, Ted Pearson, admitted to her by a supervisor that she had done most of the work and should finish the paper. She calculated the trajectory of Alan Shepard's 1961 spaceflight, which was later used for the Freedom 7 Mercury capsule. And she also calculated the launch window for Shepard's 1961 Mercury mission and performed calculations for a planned mission to Mars. And then again later, she helped calculate the trajectory launch for the 1969 Apollo 11 flight to the moon and worked on the 1970 Apollo 13 moon mission as well, where she had to help with the aborted mission and calculate a safe route for astronauts to return on. And then today, she received many honors such as NASA Lunar Orbiter Award, 3 NASA Special Achievement Awards, Mathematician of the Year in 1997, and the Presidential Medal of Freedom.
Next, we have Shakuntala Devi, and her topics of study and contribution were mathematics and astrology. And the background she came from was that like her father was a circus performer, so they were always on the move, and she did not have like formal education because they were always moving around. But she always was able to do extreme like mathematical calculations in her head. And over time, she became known as the human computer, and she became an international phenomenon for that. And she was able to make like several calculations without the aid of like a calculator or any technological device. In 1977, she actually raced against a Univac computer by calculating the 23rd root of a 201-digit number, and she extracted the correct number in under a minute and beat the computer by 12 seconds. And she also made it to the 1982 Guinness Book of World Records. And for this, it was basically, they had to multiply 2 randomly chosen 13-digit numbers. And she did that just in 28 seconds. So, and then she was also a talented writer. So she combined the fields of mathematics, astrology, and even puzzles. She really liked those. And she wrote several books about that.
Okay, Annie Easley. So she focused her research on energy conversion systems and the evaluation of alternative power technologies such as solar, wind, and battery technology for early hybrid vehicles. And these are part of her lasting impact. She was born and raised in Alabama by a single mother. She was encouraged to be anything she wanted as long as she worked hard for it. Unfortunately, she had to navigate through the racially segregated school system in Alabama, but she eventually became the valedictorian of her high school. After she graduated from high school, she started studying pharmacy in Louisiana, but she did get married and then she moved to Ohio, and there was no programs for her to attend there. So reading an article about the human computers at the National Advisory Committee for Aeronautics, she applied for a job and 2 weeks later started a career that lasted for over 30 years. At work, though, she experienced racism and sexism where she was even cropped out of a photograph of her team. She did work on several projects as a human computer. As NACA changed to NASA and machines became more prominent, she went back to school. However, NASA paid undergraduate tuition for her male counterparts and allowed them paid leave to study, which she did not receive either of. Although she was determined to graduate, so she received her Bachelor of Science in Mathematics from Columbia State University in 1977. And she later learned computer programming, specializing in Fortran, which is Formula Translating System, and SOAP, Simple Object Access Protocol. And then outside of her programming work, she volunteered as a tutor and a speaker to share NASA's work and encourage STEM participation by female and underrepresented students. She also helped change the dress code for women at NASA. And this helped other women in NASA focus on looks less feminine and more utilitarian that emphasize what work they produced as opposed to what they wore.
And there were several more amazing women mathematicians throughout history. Obviously, we could not state each and every one of them, but here's some more. Mary Cartwright, Grace Hopper, Dorothy Vaughan, Mary Vincent Jackson, and Margaret Hamilton are just to name a few more. But as we can see throughout history, how women made so many contributions to the field of mathematics even through all the struggles, and how we began with Hypatia and how she was killed for doing so. But as we progressed throughout time, they became more and more accepted, which is great. So great for all of us. And these are the references. And then these are the upcoming Association of Women in Mathematics events. But thank you so much for y'all's time.
Questions? Is the Pi Day party kind of open for people to show up?
Yes,
Okay.
it's open for, you don't have to be a math major or a woman or anything. It's open for anyone who wants to join.
You know, can you take the slide back to Katherine Johnson?
Yeah, that's what it is.
So, you know, they do a lot of those computations. It's hard to believe how important that is. Was anybody here at the astronaut scholarship talk? Okay, good. So you haven't heard the story. So the astronaut that taught. So when they land on the moon back in the day, and yes, it did happen. I think he said that the astronauts, they had 3 computers on the module. One of them controlled their descent. One of them controlled their oxygen, and there was, I forget what the other one was for. Do you know how much memory those computers have? 80K.
Wow.
It's like, let's get in a couple of wagons and go to the moon, right? So this work, I mean, save lives. I mean, that's a lot of faith you gotta have in people.
One of my favorite facts about the Native American Golda.
Yeah,
Mary Golda Ross
Ross.
is that she was one of 40 engineers who set up this sort of secretive research group at Lockheed. She was the only female in Skunk Works.
Mhm.
Have you heard of Skunk Works?
I have,
Yes.
what is it?
It's a sort of secretive research group at Lockheed. And I only heard about it a month ago.
Yeah,
There's a group in the Sudoku community called Skunk Works, and I thought, I wonder where that name comes from. I'll Google it. I couldn't find anything about it, but I could find lots about this group at Lockheed.
I've got a former student who's actually a professor at Northeastern State where she graduated. And this is, I'm glad that you all get to talk because I'm gonna send it to him. He's gonna be thrilled about that. Other questions, comments? Who's your favorite?
My favorite.
Hmm.
Oh, of dead women mathematicians?
They could be at any stage of life.
No, I mean, there are so many who are not well known, and I would love to pick one of them. There are so many who are now well known, like Maryam Mirzakhani, who is better known probably partly because of the Fields Medal, but also partly because she died so young
Yeah.
and so tragically.
Mhm.
One of the things we're hoping to do in our seminars is to bring to light some of these other lesser known stories. Of the well-known stories, I think the ones you haven't mentioned, Emily de Châtelet. Have you heard of Emily de Châtelet?
I have not.
She was a contemporary of Isaac Newton, living in Paris, and she translated much of the works of Newton and popularized them in France. And without her, Newton might not have been known in the rest of Europe. She's known of, but not well known.
Right. Yeah, I had people like that. It would be old Italian Todd.
Yeah.
But I kind of favored her because I knew her and I thought
Yeah.
that she was a fantastic person.
And
But more importantly, who's your all's favorite?
mine is Katherine Johnson.
we guessed.
Yeah.
I don't really have one, honestly. All of them have made their like significant contributions, so.
I can't
Yeah.
do anything in my research without seeing Emmy Noether's
Yeah.
fingerprints on it. Nothing, right? So.
Who's your favorite, Eliza?
I don't know, I'm sitting here trying to figure that out as well. I mean, I'm, of course, I'm deeply partial to my advisor, Joanne Cohen, but, you know, that's just. Not only do I like the mathematics that we did, but I liked her as a human being and the contributions that she made to broadening participation and opening doors for people from all sorts of populations that were not well represented in the field. She's still alive and active, so she doesn't fall in the category of dead women mathematicians at all. So, but I think that was actually a safe boundary put there, especially given,
Yeah.
live women mathematicians all sort of looking at you, like, yeah, who are you gonna pick there? How about, do you mind if we open it to the other students, or, so toss out the names, who are you hoping to interview and tell the stories of?
Oh, I can go. So our class, we were telling the stories among some women in math. So we basically picked a woman in math that maybe doesn't have their story well known at all, and we're going to interview them and try to get information about them out there. I'm going to interview Leanne Cushing, who is most people probably know her from BattleBots. She was the lead design engineer for the Valkyrie robot on there, but she currently works at Apple as a product design engineer, and she's done a lot in robotics, so worth that.
Going in line, okay. Well, I'm gonna interview Dr. Carolyn Purcell. She was a former executive director for the Association for Women in Mathematics, and she also works as part of, I think, Service Robotics and Technology. So she works in robotics and part of a tech company, doing a lot of math stuff there.
I'm doing a researcher at Ohio State University, the Ohio State University, sorry, called Brantley Edmonds. And she developed like a case study there to research other Black women in math, and that's pretty cool. I'm excited to talk to her. She's pretty young, so nothing crazy yet, but she seems very interesting. Your turn.
I hope to be able to interview a lady named Marcel Cruz, who does a lot of statistics related to health and obesity.
It's been a lot of fun hearing your.
Yeah.
How did you choose the ones with, actually, let me ask, not just your favorite, but which story excited you the most as you were researching this women in that?
The one about Sophie Germain really stood out to me, about like how her parents were not accepting, but she still was so passionate for mathematics that she would work throughout the night, even with frozen eggs. So that one really stood out.
We actually did a presentation in our class about Sophie Germain.
Another one I really like is Julia Robinson.
Yeah.
Um,
Sure.
who worked as a lecturer, not in a tenure track position at Berkeley for years, until she solved one of the Riemann, the Hilbert open problems. And suddenly they transferred her lecturer lowly status into full professor. Her husband had been a full professor in the department for years, but she was just regarded as, because she solved the Hilbert problem.
Show them.
Mhm.
Jordan, how about you? Which story excited you the most?
Honestly, like all of them. I learned a lot, like John Hobby did most of like the research and stuff like that, but I learned a lot like looking through and just, I guess, seeing how different mathematics looks today than it did like years ago. So they're all great stories, great contributions, and I'm glad to see like the progress that's been made today. Like, we can't wait to see like what's in the future as well.
Should tell a story about the physics.
Yeah, have you heard about the woman who won the physics Nobel Prize? It was like 4 or 5 years ago. And people have been trying to get a Wikipedia page set up for her for a while, and they kept getting dinged as this isn't notable enough. She is not notable enough. She is not notable enough. And one day she gets a call from the Nobel Committee. Suddenly they approved a wiki page for her. Sort of akin to the Julia Robinson story.
5 seconds ago, you weren't notable until you got that press.
How hard was it to find information about these women?
I had to look at several different sources, and Kristen Severy from the Association for Mathematics, she helped a lot, and she had like a book on all of these women, so that book was very helpful.
Or we're dominating. We should, I'm gonna hush now. I'm not gonna say anything else for at least 4 minutes. So.
I can say it. So I'm a computer science major, so I'm kind of partial to like women in computer science and then within mathematics. So I think on the last slide you had Grace Hopper. So she's definitely somebody that had a big impact, particularly in my life. Because I mean, I didn't know her, but of course I'm computer science, so she was I think the creator of C programming language. So she's yeah, definitely one of my top 5 favorite mathematicians.
Also responsible for the coining of the word bug.
Yes, exactly. Yes.
There was something wrong with
Plenty of those.
something, and it was actually a physical bug, some sort of a roach or something like that.
Familiar with that part of mine.
I thought that was where you were gonna say.
But yeah, yeah.
And I do my work with Jim, and so of course, Emmy Noether I run into all the time in there, but my advisor from my undergrad institution always extolled her virtues, and I believe she was either his grand advisor or great grand advisor. His advisor and his PhD advisor of them was Emmy Noether, or maybe one more step removed. From all accounts, she was very, very, very good at what she did, obviously, but also expected a lot from her students.
I've always heard that that the expression abstraction simplifies comes from her. And I've found that, you know, of course, that's not a universal truth, but it's true surprisingly often.
Like the biggest thing in abstract algebra is Noetherian rings. Everything has to be Noetherian, because if it's not, it's just the worst thing in the world.
Other questions, comments? Yes.
Like reading the story of those women, how does it inspire you and how does it make you feel like does that inspire you to do something for the other women in this world right now that doesn't have access to math at all, ever, not only math but also education in general? How does it inspire you?
No, yeah, that like inspires me for sure. I mean, I hope to like, as I progress with my mathematics degree to, you know, like maybe start a nonprofit or something for those who don't have opportunities in mathematics and such, like women and men, like everyone across the world. So yeah, all of these women are super inspiring to, you know, start that and yeah. Any other questions?
Well, let's please thank our speakers again. Okay, everybody. Well, I believe we've got one more of these before spring break, and we will have a math club next week. Should be a lot of fun. So y'all have a great weekend and hopefully we'll see you.